Let's take a look at the homework we had last night, page 453, questions 1 to 2, 5 to 9, 11, and 13 to 16. Any issues with any of those questions on page 453? Yeah. 6? Any others? 16? Number 7 as well? 15? 6, 7, 15, 16? So much for my little theory. Number 6. So I had 3 examples of situations in which velocity is the dominant factor for the momentum, affecting the momentum of an object, and 3 examples in which mass is the dominant factor. Somebody asked me about this yesterday, and I can't remember who it was, but exactly what do we mean by that, the dominant factor? And I went through a couple examples, and then I think it became pretty clear what we meant by this. Mass and velocity both affect momentum. The higher the mass, the more the momentum, the harder it is to stop the object. The higher the velocity, the harder it is to stop the object. In other words, the more momentum. So the question is, when is mass the more important factor in momentum? When is velocity the more important factor in momentum? I gave an example yesterday to somebody. You got a train moving down the track in a train yard that's going very, very slowly. Like it's barely moving. But you don't want to stand in front of that train because that train is still difficult to stop. In other words, that train still has a lot of momentum, even though it's moving slowly. Why? Why does it have a lot of momentum, even though it's moving slowly? Because it's heavy. It's got a lot of mass. So in that case, mass would be the dominant factor in the momentum of the object. Does that make sense? Okay. So we're looking for situations like that where mass is the dominant factor, and we're looking for situations where velocity is the dominant factor. Okay. 3, 2, 5, whatever. Doesn't matter how many we come up with here. It's just the idea of thinking about that. Okay. Anybody have another example of mass situation in which mass is the dominant factor? Or velocity, either one? Okay. Okay. Race, yeah, it's a good example actually, because race cars are actually pretty light, right? Compared to, some of the cars that we have on a road, or a race car is pretty light. But it has a lot of momentum, right? It has a lot of momentum, and largely it has that momentum because of its velocity. Now, it's still heavy, compared to a bicycle, but so part of its momentum is certainly due to its mass, but it's going at 200 miles per hour, like 300 and whatever kilometers per hour. Its momentum is largely due to that velocity, right? That's the dominant factor. Good. Another example? Yep. Okay, give me some more detail on that one. Okay. Perfect example right there. So a moving bullet is a perfect example of when velocity is the dominant factor. It's difficult to stop that moving bullet, right? You don't want to stand in front of it. It's difficult to stop it, not because it's heavy. Bullets are very, very light, but because it's got a lot of velocity. Velocity would clearly be the dominant factor then. Emma? Okay. You stole your answer, hey? Yeah, I was thinking of a bicycle. Okay. My bike is pretty light. If I go down the hill by Fountain Tire there, I might be going 50, 60 kilometers per hour down that hill. It's hard to stop. When you're going 50, 60 kilometers per hour on your bike, it's difficult to stop. You've got a lot of momentum behind you. But largely that momentum is due to how fast I'm going as opposed to how heavy the bike is and how heavy I am, right? Okay, we get it, guys? That make sense? I mean, if you worked hard enough, you could think of 1,000 examples of each of those, right? The idea is just to get the basic idea behind it, though. Okay, 7. This is actually my favorite question on this page, Devin. It is, I guess, it's a number of perfection, right? So it is the perfect question, perhaps. A Mexican jumping bean moves because an insect larva inside the shell wiggles. Would it increase the motion of the mass to have the mass of the insect greater or to have the mass of the shell greater? Let's do a little poll here. Who says it would increase the motion to have the mass of the insect greater? Hands up. Oh, wow. Everybody. All right, well, then why? Let's hope you're right. Everybody is saying that. Why? Why the mass of the insect as opposed to the shell? You are right, by the way. So now you can be confident, at least in how correct your answer is. Now go out on a limb and tell me why. Really? Yeah. Yeah. What transfers momentum to what? Okay. It's the insect transferring momentum to the shell. Do you want to have something with lots of momentum transferring momentum to something light? Or do you want to have something with a little bit of momentum transferring momentum to something heavy? Okay. Well, if you want the shell to move, you want to have something, i.e. the insect, with lots of momentum transferring it to something that is light, the shell, versus the other way around. It's kind of like if you want, if you're driving on the car, or sorry, driving on the highway in your car, and you hit something. Okay, if you want that something to move, like if you want that something to fly out of the way so that your car doesn't come to an abrupt stop and you don't get injured in your car crash, what do you want that object to be? Do you want it to be one of those orange traffic cones that are really, really light? Or do you want it to be something that's, this massive concrete pillar that's really, really heavy? Well, if you want to get that cone moving so that you don't come to a crashing halt, you want it to be something light, right? The orange cone, because that's going to move more than something that's heavy. All right, next one was 15. The blue whale is the largest mammal ever to inhabit Earth. Calculate the mass of a female blue whale if, when alarmed, it swims at a velocity of 57 kilometers per hour and has a momentum of 2.15 times 10 to the 6 kilograms meters per second. We want to find the mass. So let's say P is equal to M times V. Let's rearrange that. M is equal to P over V. The momentum is 2.15 times 10 to the 6 kilograms meters per second. What do we got to do with the velocity here? What's wrong with this velocity right now? Yeah, Tom? Right, it's in kilometers per hour. We got to get it in meters per second. What's the shortcut for that? Yeah, divide by 3.6. And what does that work out to be when we divide by 3.6? 15.83. Okay, so whatever 2.15 times 10 to the 6 is, divided by 15.83 is what we get there. Okay? Okay, 16. A loaded transport truck with a mass of 38,000 kilograms is traveling at 1.20 meters per second to the west. What's the velocity of a 1,400 kilogram car if it has the same momentum? A little bit of a tricky question, actually. The transport truck has this mass and this velocity. What's the velocity of the 1,400 kilogram car if it has the same momentum? Okay, when I see this, I see one word that kind of jumps out at me as being really important here. Anybody see a word that kind of jumps out at them as being really important? It might not seem like a really important word on the surface, but it ends up being pretty critical to this question, the crux of the question, in fact. Same. Anybody spot that? Anybody think, oh, wait a sec, that's a big word there. The same momentum. What does that tell us? Well, let's get the momentum for the first vehicle and then set that equal to, they're telling us it's equal to the momentum of the second vehicle, right? So let's get that. The momentum of the first vehicle is 38,000 times 1.2. What's that equal? 7,600 is 45,600. Is that right? 45,600 kilograms meters per second. All right, good. Momentum of the first vehicle. Well, we know now that that's also equal to the momentum of the second vehicle. We want to find the velocity of the second vehicle, Let's rearrange it. Let's say now 45,600 kilograms, meters per second, divided by the second mass of 1,400 kilograms. What do we get there? 3.30 point something, isn't it? Or 31 or something like that?
Yes, 32.5 or
32 point what? Let's go 3 digits.
5.7.
Okay, so 32.6 meters per second, right? Because we went back to that as our original pieces of data, 3 digits. 32.6 meters per second. All right? Again, the big word there is the word same. But I'll tell you what, even if you didn't spot that right off the top of this question, there will be questions where you don't necessarily know exactly what to do. You don't necessarily spot that crux of the question right away. And that's okay. Okay? If you don't know what to do with this question at the beginning, just do something. What's the first thing you would do if you don't really know how to solve this question? Hey, look, I got a mass and velocity of the transport truck. Let's find it. Let's find its momentum. Okay. Where's that going to lead me? I might not know right off the top. That's okay. Find it anyways. Because sometimes when you don't know what to do and you find something, sometimes a light bulb goes off in your head after you've found that something. Says, oh, wait a second. I see what I'm going to do with this number now. Sometimes it just takes a matter of getting that number. Okay, so don't panic. You don't recognize that these two should be set equal right away. That's okay. Just get the momentum of the first thing because you can. And then maybe that light bulb will go off to help you do the rest of the question. All right?